Hello student, welcome to the lecture series of complex variable and partial differential equation. In previous lecture we have studied about exponential form of complex number, polar form of complex number, modulus of complex number and argument of complex number. Okay, so in this lecture we will learn about some examples of related previous lectures and de Moivre's theorem. Okay, so let's take first example, that is express under root of 3 minus I into polar form. So here you can clearly see that our polar form, that is z is equal to r cos theta plus I sin theta. Okay, so here we have z is equal to root 3 minus I. To represent it in polar form we need r and theta. Okay, so r is nothing but under root of x square plus y square, and theta is nothing but this is under root of 3 minus I. So this complex number which is in fourth quadrant. So theta is equal to minus tan inverse mod of y by x. Okay, so here you can clearly see that our x is equal to under root of 3 and y is equal to minus 1. So r will become under root of root 3 raised to whole square and plus minus 1 raised to whole square. Okay, so this is under root of 3 plus 1, this is under root of 4, so we can say that r is equal to 2. And here we have theta, that is minus tan inverse y, that is minus 1, and x, that is under root of 3. Okay, so this is nothing but minus tan inverse 1 upon root 3. Okay, so this is 1 tan inverse 1 upon root 3, that is pi by 6. This is minus pi by 6. So our theta is minus pi by 6 here. Okay, so the polar form representation of root 3 minus I, that is z is equal to r, that is 2, theta, that is minus pi by 6, but for cos negative value of theta this will become plus cos theta, so this is cos pi by 6, and negative value of theta for sine will become minus sine theta, so this one is minus I sine pi by 6. Okay, so this is the polar form representation of complex number root 3 minus I. Second is find the principal angle of 1 upon root 3 plus I. Okay, so for principal angle here we can clearly see that here we have 1 upon root 3 plus I, but to find out principal angle we need value of x and value of y. So here we have to find value of x and value of y from this equation. So here we have 1 upon root 3 plus I. Take conjugate, so this is root 3 minus I upon root 3 minus I. Okay, so this will become in numerator, this is root 3 minus I, and in denominator this will become a plus b, a minus b, so this is root 3 raised to whole square minus I raised to whole square. Okay, so this will become root 3 minus I upon root 3 raised to whole square, that is 3, and minus I square, that is minus 1, so this is 4. So this is root 3 by 4 and minus I by 4. Okay, so the principal angle. Okay, now here you can clearly see that our z is equal to root 3 by 4 and minus I by 4. Okay, so we can say that x is equal to root 3 by 4 and y is equal to minus 1 by 4. And you can clearly see that this complex number which is in fourth quadrant where x is positive and y is negative. So fourth quadrant principal angle theta equation, that is minus tan inverse mod of y by x. Okay, so this is minus tan inverse y is minus 1 by 4, x is root 3 by 4. Okay, so this is nothing but minus tan inverse 1 by root 3, and tan inverse 1 by root 3, that is pi by 6. So here we have minus pi by 6, our principal angle theta. Okay, next question is solve the equation z square minus 5 plus I into z plus 8 plus I is equal to 0. Okay, so here you can clearly see that this is the quadratic equation of z, where a is equal to 1, b is equal to minus 5 plus I, and c is equal to 8 plus I. Okay, so to solve this we have to use delta is equal to b square minus 4ac. So here b is minus 5 plus I, but b square, so this will become 5 plus I raised to whole square minus 4 is 1, c is 8 plus I. Okay, so this is 25 plus 10I plus I square minus 8 fours are 32 minus 4I. Okay, and I square is nothing but minus 1. So this will become 25 plus 10I minus 1 minus 32 minus 4I. Okay, so addition of real part, that is 25 minus 1 minus 32. So minus 33 plus 25, this will become minus 8. Okay, and plus 10I minus 4I, so this will become plus 6I. So this is the value of delta, but here we have to find under root of delta. So this will become under root of minus 8 plus 6I. Okay, so here we have to find under root of complex number. Okay, so here we have some equation to find out under root of complex number. Okay, which is in the form of x plus or minus iy. So this is a shortcut method to find out under root of complex number. So this is equation, that is plus or minus under root of mod z plus x by 2 and plus or minus I under root of mod z minus x by 2. Okay, so here in this situation we have complex number here minus 8 plus 6I. So here x is equal to minus 8 and y is equal to 6. Okay, so under root of minus 8 plus 6I, according to this equation will become plus or minus, we will use this formula, that is under root of mod z plus x by 2 and plus, if here y is positive, so put plus here, if y is negative then put minus here, so plus I under root of modulus of z minus x by 2. Okay, now here you can clearly see that we need modulus of z. So for this minus 8 plus 6I, modulus of z, that is under root of minus 8 raised to square and plus 6 raised to whole square. So this is nothing but 64 plus 36. So this is under root of 100. So this will become 10. So here we have modulus of z, that is 10. Here x is minus 8. So now we have answer, that is plus or minus mod of z, that is 10 minus 8. So this will become plus 2 and 2 by 2. This will become plus 1 and under root of 1 will become plus 1. Okay, here we have modulus of z, that is 10 minus x, so minus minus plus 8, so 10 plus 8 divided by 2, so this will become 9 and under root of 9, that is 3. So this is our plus or minus 1 plus 3 I answer. Okay, now we have already find, that is under root of delta is nothing but plus or minus 1 plus 3I. Okay, so solution for this quadratic equation will become z is equal to minus b plus or minus under root of delta divided by 2a minus b, that is minus 5 plus I, and this is minus minus plus because already we have b in negative form. Here plus or minus under root of delta, that is 1 plus 3I, and divide by 2a is equal to 1. So here we have first plus value and second negative minus value. So z1 is equal to 5 plus I plus 1 plus 3I by 2 and z2 is equal to 5 plus I minus 1 minus 3I by 2. Okay, so addition of real part, that is 5 plus 1, that is 6 and plus I plus 3i, that is 4i divided by 2. So our first value, that is 3 plus 2i, and here addition of real part, that is 5 minus 1 is 4, and here I minus 3i, that is minus 2i divided by 2. So our second value will become 2 minus I. Okay, so this is the solution for our question, that is quadratic equation, which is in second order form. So here we get two roots of that quadratic equation. Z1 is equal to 3 plus 2i and Z2 is equal to 2 minus I. Both are in complex form. Okay, next is, what is de Moivre's theorem? Okay, so if n is an integer, positive or negative, then cos theta plus I sin theta raised to n is equal to cos n theta plus I sin n theta. Okay, in second language we can say that cos theta plus or minus I sin theta raised to n is equal to cos n theta plus or minus I sin n theta. Okay, for example, we have question that cos theta plus I sin theta raised to 2. So we can say that, we can write like this: cos 2 theta plus I sin 2 theta. Also we can use it in reverse form. Okay, for example, we have proved that cos theta minus I sin theta raised to 7, cos theta plus I sin theta raised to 10, cos theta plus I sin theta raised to 15, and cos theta minus I sin theta raised to 12. Okay, both are in denominator, is equal to 1. Okay, so according to de Moivre's theorem, here cos theta minus I sin theta raised to 7. Okay, so here according to de Moivre's theorem we can use, okay, here we can use also, this is plus or minus, plus or minus. Okay, so for example, we have cos theta minus I sin theta raised to n, so also we can write like that: cos n theta minus I sin n theta. Okay, remember this. So here we have cos theta minus I sin theta raised to 7. So according to de Moivre's theorem, in numerator we can write like this: cos 7 theta minus I sin 7 theta. This is also cos theta plus I sin theta raised to 10. So we can write like this: cos 10 theta plus I sin 10 theta. Okay, and in denominator this is cos 15 theta plus I sin 15 theta, and here also cos 12 theta minus I sin 12 theta. Now we know that cos theta plus I sin theta is equal to e raised to I theta. We can write like this. Okay, so here we can write this cos 7 theta minus I sin 7 theta, and also we can say that cos theta minus I sin theta is equal to e raised to minus I theta. Okay, so cos 7 theta minus I sin 7 theta is nothing but e raised to minus I sin theta into, this is e raised to I 10 theta upon, this is e raised to I 15 theta into e raised to minus I 12 theta. Okay, now addition of power in exponential form. So this is e raised to 10I theta minus 7I theta. So this is 3I theta. Okay, and in denominator this is also e raised to 15I theta minus 12I theta. So this is nothing but e raised to 3I theta, because we know that e raised to 2 into e raised to 3. So this will become e raised to 2 plus 3. So this is nothing but e raised to 5. Okay, so now this both are cancel out. So our answer is 1. Okay, now let us understand with next example, that is evaluate 1 plus I raised to 7 plus 1 minus I raised to 7. Okay, so here we have first case, that is 1 plus I. Okay, so here you can clearly see that x is equal to 1, y is equal to 1. So for this case, r is equal to under root of x square plus y square. So that is 1 plus 1. So this is under root of 2. okay, and theta, this one is in first quadrant, so tan inverse y by x, so this is tan inverse 1, so theta is nothing but pi by 4. Okay, so we can write this complex number in polar form like this: 1 plus I is equal to polar form, what is r cos theta plus I sin theta. So for this complex number 1 plus I, our r is under root of 2, so this is under root of 2. Theta is pi by 4, so this is cos pi by 4 plus I sin pi by 4. Okay, first of all convert it in polar form and then try to solve it. Okay, next value is 1 minus I. So for 1 minus I, x is equal to 1, y is equal to minus 1. So we can say that for this r is equal to under root of x square plus y square. So that is 1 plus 1, that is under root of 2. And theta, here you can clearly see that 1 minus I, which is in fourth quadrant. So for in fourth quadrant, theta is equal to minus tan inverse y by x. So this is minus tan inverse 1. So this is nothing but minus pi by 4. Okay, so we can write this 1 minus I in polar form like this: r cos theta plus I sin theta. So r for 1 minus I, that is under root of 2 cos theta, but cos minus pi by 4, but in cos case, if theta is negative, so answer is plus cos theta. So this is cos pi by 4, but in sin case, if theta is negative, so answer will be minus sin theta. So this is minus I sin pi by 4. Okay, now here we have evaluate 1 plus I raised to 7 plus 1 minus I raised to 7. So now we have polar form of 1 plus I and 1 minus I. So we can use here, that is root 2 into cos pi by 4 plus I sin pi by 4 raised to 7. Okay, and polar form of 1 minus I, that is again root 2 cos pi by 4 minus I sin pi by 4 raised to 7. Okay, so here this is nothing but under root of 2 cos pi by 4 plus I sin pi by 4 raised to 7, and this is under root of 2 raised to 7. Okay, here under root of 2 raised to 7, this is again cos pi by 4 minus I sin pi by 4 raised to 7. So this is nothing but cos theta plus I sin theta raised to 7. So here we can use De Moivre's theorem easily. Here also cos theta minus I sin theta. So here again we can use De Moivre's theorem easily. Okay, so according to De Moivre's theorem, and by taking root 2 raised to 7 common from both this term. So this is root 2 raised to 7 common, and by using De Moivre's theorem directly, so this is cos 7 pi by 4 plus I sin 7 pi by 4, and by taking this 2 raised to 7 common, so this will become again plus cos 7 pi by 4 minus I sin 7 pi by 4. Okay, so this both are cancel out. So this is nothing but root 2 raised to 7 2 cos 7 pi by 4. Okay, so root 2 raised to 7 into 2 is nothing but 16 root 2, and this is cos 7 pi by 4, so this is cos, this is 2 pi minus pi by 4. Okay, now 2 pi minus pi by 4, so for example we can easily understand here, this is 0, this is pi by 2, this is pi, and this is 3 pi by 2, and here also we have 2 pi. Here according to all STC rule, 2 pi minus pi. Okay, so 2 pi minus pi, this is in fourth quadrant, and in fourth quadrant cos is positive. So here this answer will become 16 under root of 2, and this is nothing but cos pi by 4, and cos pi by 4 answer is 1 upon root 2. So our final answer is 16. Okay, So here we can use de Moivre's theorem to solve many examples, and we can easily solve many examples according to de Moivre's theorem. Thank you for watching this video.